R is equal to that quantity. So if I do the substitution, and let's do this very quickly, okay? So take the magnitude of T of j omega. Omega is equal to omega r is 1 minus r square, which is square root of 1 minus 2 zeta square whole square, or 1 minus 2 zeta square whole square, and then 2 times zeta times r whole square, so that's 2 zeta 1 minus 2 zeta square whole square, all of this square. Clearly there is some algebra involved here, and all good things have some algebra involved. I will not go through the algebra. If you go through the algebra, which I have done in my lecture notes, this is called T peak. You will end up getting T suffix p as 1 by 4 this is the peak of at omega r is that, or r is equal to you can either substitute for omega or r. Obviously it's easier to substitute for r. And so you see, if a person comes and says, hey, I don't need damping, to hell with it, which means zeta is 0, what happens to the peak value? Infinitely large, right? It's quite obvious to see that if zeta is 0, this is 1 by 0, and 1 by 0 is mostly infinity. And so the moral of the story, and we're going to come back and we're going to do some qualitative analysis on this expression. So hang on, I have a few more minutes left. So what we're going to do is we're going to come back, plot the behavior of the magnitude of the frequency response function as a function of omega, and then we will go into the body plot for the second order system. After doing the qualitative analysis, there is still some stuff left to do. Okay, and sometimes this creature, under certain circumstances, is called as the quality factor. The quality factor is important for electrical engineers, not so much for us, because what do I want in life? I want some damping. If I'm a mechanical engineer, obviously I'm going to put damping, because it's common sense. If I don't have damping, then all hell breaks loose. Okay, thank you.